Hey there, fellow physics studentos. Today we're going to go through the Jumping Joe simple problem, and I'm going to just do this example and kind of run you guys through it. So let's write down our variables that we know and get into solving this thing. Alright, so Joe and his bike have a mass of 27.5 kilograms. And he's moving with a steady 18.0 meters per second squared. And he won't lose any speed on the ramp. The ramp is angled at 20.9 degrees above the ground. We're going to determine his range that he travels flying off of the ramp as a projectile. And the gravitational field on this planet is 6.8 meters per second squared. Alright, so if we hop over here in this area, we can see all the variables. We wrote down the mass, the initial velocity, which was that 18.0 meters per second, the gravity, and the angle theta. So the first order of business is to solve velocity in the x direction. And we're going to do that by drawing Joe as this little diagram here. And this is velocity in the y, this is velocity in the x, and this is the initial velocity. And then theta, of course, is right here. And so using basic trigonometry, we know that the velocity in the x is going to be equal to the initial velocity times cosine of theta. And so Vx is going to be equal to the initial velocity 18.0 times the cosine of 20.9. And let me grab my handy dandy calculator here and ask it nicely, what is 18 times cosine of 20.9? And the calculator says 16.8 meters per second. And make sure you are in degree mode, because radians won't work with this type of problem. But nevertheless, we now have our first variable, velocity in the x. So let's just go ahead and box this up and write it over here for future reference. And next we're going to calculate the time. And by using some trigonometry and simple replacement of variables, we can derive the equation t equals 2 times the initial velocity times the sine of theta divided by the gravity. And I would definitely recommend writing this equation down. It's helped me a ton. Can't recommend it enough. So, and this equation works in our favor very well because we have all three of the variables here. We have the initial velocity, we have the gravity, and we have the theta angle. So we're just going to go ahead and plug and chug all these numbers into the equation. So 2 times 18 times the sine of 20.9 over 6.8. And if we churn that all out, make sure you do order of operations. So 2 times 18 is 36 times the sine of 20.9 is 12.842 ... divided by 6.8. And if you plug and chug all of this equation, we get t equals 1.9 seconds. And look at that, we just got our second variable here. And lastly, we have to calculate for the range, and the range is Vx times t, and we have both of those variables now. So r is going to be equal to 16.8 times 1.9. And this is the easiest equation in this whole problem. And the range from our calculator we got was 31.92 meters. and box that answer up because it's our last one. Write it in if you feel like it. 31.92. And now we're going to plug it into the website and see if our answer holds up and if it's correct. So let's try that out. Okay, so here we are back at the website. Let's go ahead and enter our answers. So enter your name. My name is Dom. Your name might be different. And the horizontal distance that we got was 31.92 meters. And let's go ahead and type that in and then click on Joe and see if we got our answers right. There he goes. And great, our answers were correct. So hopefully this video and this example helps you out. Hope you get correct answers too. If not, let me know if you have any questions, and thanks for watching.